Hi, it's Miss Townsend. Let's try this question together. We have a quadratic relation in standard form, and we're asked to find the roots, the axis of symmetry, and the vertex. Well, because we know how to factor, we can try factoring it because that's the fastest way to find the roots. So that'll be our first approach. To find the roots, which are also the x-intercepts, we're going to let y equal 0, and then we're going to have a look at the actual standard form quadratic expression and see if we can factor it. So the first thing I notice is that all of the numbers, the coefficients, are divisible by 2. So I know I can common factor 2. And I also see that the first coefficient is negative. And that means I definitely want to factor negative as well as the 2. So my first step will be common factoring negative 2 and seeing what else happens. So common factoring is essentially like dividing, but without actually changing the expression. So negative 2x squared divided by negative 2 is x squared. Negative 16x divided by negative 2 is positive 8x. And positive 18 divided by negative 2 is negative 9. So that means I've common factored out my common factor of negative 2. And what I have in the bracket is something I should now attempt to factor. And what I have in the bracket is a simple trinomial. And we know that if we have a simple trinomial, we should be able to factor them, if they're factorable, just by finding the two numbers that multiply to negative 9 and add to 8. So negative 9. Well, the only numbers that multiply to 9 are 1 and 9, or 3 and 3. So 3 and 3, if I added them, I would get 6. If I subtracted them, I would get 0. And no matter what I did with positive or negative signs, I'm only ever going to get 6 or negative 6 or 0. And I don't want those. I want 8. So 1 and 9 are the two numbers I need, and I need to add to positive 8. So if I make the 1 negative and the 9 positive, those will add together to give 8 and multiply together to give negative 9. So that means this quadratic factors to negative 2 times x minus 1 times x plus 9. So I factored it, and now I can find the roots very quickly, because once it's in factored form, I can apply the zero principle. And that says if this bracket is 0, then it doesn't matter what this bracket is, and it doesn't matter that it's multiplied by negative 2, because anything times 0 is equal to 0. So what value of x makes that bracket 0? Well, the value would be 1. So one root is at x equals 1. And then I'm going to apply the same zero principle here. I have another bracket, and it says x plus 9. So what value of x makes that bracket equal to 0? Well, that would be negative 9. So those are my two roots. Sometimes we call them x-intercepts still. So if I wanted to write them as x-intercepts, I would write that. But it's okay to leave them as roots, which is just where you tell me what x is equal to. Now that I have the roots, I need to find the axis of symmetry. So if we visualize to remind ourselves what we're doing, here's the xy axis, sort of. I have a root way over here at negative 9, and I have another root at 1. And we know that except for the vertex, every point on a parabola has a horizontally symmetrical point. So these 2 points are horizontally symmetrical, and really that means that exactly halfway between them is the axis of symmetry. So if I can figure out what number is exactly halfway between negative 9 and 1, I'll know where the axis of symmetry is. So we can do that using the midpoint formula, which is also just finding the average of two numbers. So my roots are 1 and negative 9, or negative 9 and 1. And so if I add them together and divide by 2, I get negative 8 over 2. So I get negative 4. So that means that the axis of symmetry is the equation x equals negative 4. So that is the vertical line that I've already drawn in red. I now know that it's at negative 4. And we can tell just quickly that between negative 9 and 4 is 5 units. Between negative 4 and 0 is 4. So another unit, that's also 5. So we can see the symmetry even with a quick sketch. We don't need to make the sketch, but I figure if you're here and needed help, I would help as much as I could. So now that you have the axis of symmetry number, we remember that the axis of symmetry is where the vertex always lies as a point. And the reason why that's so important is because it means that the x value of the axis of symmetry is the x part, or the x coordinate of the vertex, which means I know half of my vertex. And now I just have to sub that value in for x to the equation. So I'm going to scroll up, because you can choose to sub it into either the original equation, the standard form version. I could sub -4 there, or I could take the factored version. I'd have to replace the 0 with y, and I could sub it in there. And that's the one I'm actually going to do. So hopefully I'll remember what I've written above. Y equals -2, x plus 9, x minus 1. So that's the quadratic relation. And it's the relation because you have both x and y in it. And it's the factored version. So now I'm going to sub x equals 4 into my x values. And following order of operations, calculate what y is. So -4 plus 9, -4 minus 1. So inside those brackets, I have 5. And the other bracket is -5. So now I have -2 times 5 times -5. So just doing that in my head real quick, I know that those are -25. So I have 50. So that tells me that my vertex is at -4, 50. And just one other really quick thing, I'm going to go back to my sketch for a second. I know that the vertex is at -4, 50. Now I'm not going to attempt to make like a beautiful graph. I'm actually just going to use this graph still. Because I know that the vertex is somewhere up here because the y coordinate is 50. So for this parabola to have roots at -9 and 1 and a vertex up here, it must be a down or negative parabola. And if we go right back to the original equation, we can tell that it's definitely a negative parabola. So there's lots of little cool built-in checks you can do along the way, especially if you make yourself a quick little sketch. Hope that was helpful. Practice math.